In this video, we're going to cover the 6L80 and 6L90 mechanical operation and power flow. This list here, straight from Wikipedia. I feel like I have to disclose that, so it's not 100% accurate, probably. You could see in about 2006, this transmission came out. Really, it was probably around 2007 or 2008 that it became kind of a staple as far as like the trucks and so forth like that, like Tahoe and Yukons and the Silverados. They all got it in the late 2000s there. And it's still being produced today. It's still being used. Matter of fact, you can still get it on a Silverado. There's some options that will allow you to get the 6-speed. And they're slowly being replaced by the 8 speeds and the 10 speeds. And I'm sure the 10 speed's probably going to be the kind of their signature transmission in the future. But they still have it available. The 6L80 or the 6L90 is still available on some of these vehicles. You can see the Silverado is still an option in it, and the Chevy Tahoe, the Denali, so the 2500, 3500 Chevy Express vans, they still have it. The Escalade. You even notice down here the 6L50, the Chevy Colorado still has it listed as its option. So it's going to be around for a while, and it's definitely going to be in the shops for a long time. There's millions upon millions of these units that are out there. So, and you can also see they use them in a variety of BMWs. As far as the features are concerned, this transmission weighs about 215 pounds with the converter and fluid. And that's actually not that much. That's a pretty light transmission. So especially for something that goes behind engines that produce a decent amount of torque. Now I do have to disclaim here that I'm not certain if these specs have changed a little bit over the years. This is what was listed on the tech guide, and I think it was published in 2007 or 8, so it was when the transmissions first started coming out. So it's not, there's a good chance that there's some changes to it. I do know that the fluid, they're still using Deck 6, and these are the gear ratios that are listed for this transmission. One thing that you might note is that with all these gear ratios, there is no direct drive. You're like, whoa, wait a minute. Usually with the rear-wheel drive transmission, all they'd have to do is drive 2 parts and hold nothing, and you get a 1-to-1 gear ratio. And you don't appear to have that. And the reason why is because the way this transmission is configured, they don't really have the ability to drive 2 parts at input shaft speed. They can drive the rear carrier at input shaft speed, which we'll see later on. Everything kind of in this orangish color here. But they don't have the ability to drive any other gear set part at input shaft speed, because this blue shell is always going to operate at a gear reduction because of the way it's configured. There's a planetary gear set up front, and it forces this shell, which drives the rest of the gear set, at about a 1.5 to 1 gear reduction. So basically we're feeding the rear gear set either directly from the input shaft, or we're feeding it at a 1.5 to 1 gear reduction. One of the gears. So we'll see that more when we cover power flow. This is the range reference chart, and one of the things I like about what GM does is they name their clutches based off of the gear that they're being used on. So we have a 1, 2, 3, 4 clutch, a 3, 5R clutch, and a 4, 5, 6 clutch. These 3 right here are all driving clutches, or we'll call them input clutches. And then we have a 2, 6 clutch and a low reverse clutch. Those are holding clutches. And then also our low Sprag, it's going to hold in one direction. And the direction that's going to hold is going to be holding in the counterclockwise direction as viewed from the front of the transmission. If you take a look at when it's being applied, it kind of makes sense. The 1, 2, 3, 4 clutch is applied in 1, 2, 3, 4. The 3, 5R is applied in reverse, 3rd and 5th. 4, 5, 6. So I don't need to go down the list there. The only thing that's probably not as clear is that this low reverse clutch, it is applied in park and in neutral. And they do that because when you first start this vehicle up and you're sitting there in your driveway, garage, or whatever, they know you're going to be going in one of 2 positions. They're going to be going either into reverse or into drive. Well, in reverse or drive, especially reverse, you need to have this applied, the low reverse clutch applied in reverse. And then all they'd have to do is apply the 3.5R clutch, and you get reverse engagement, and then you're backing out. All the manufacturer has to do when you shift into reverse is concern themselves with applying the 3.5R clutch smoothly, and then you got a nice quality shift into reverse, or engagements. If you remember, we call those garage shifts. And if the driver ends up engaging drive, so if they're going from park or neutral to the drive position, all you're really doing is applying the 1, 2, 3, 4 clutch. Yes, you do have this low reverse clutch applied for a moment as it releases, but we're allowing our low Sprag assembly to hold the same component that the low reverse clutch would be holding, which is the Ravenel carrier gear set that we've got. So they don't need it to drive in first gear. They don't need the low reverse clutch to be applied. It doesn't hurt to have it applied because it's holding the same part that the Sprag is going to be holding. So it's not like it puts you in a bind or anything like that. But by applying that low reverse clutch while I'm in park or in neutral, you basically created a situation where it only has to apply one clutch when you shift into reverse. And that's going to prevent delayed engagements, and it's also going to possibly prevent weird garage shifts. So other than that, this is pretty simple. We only have 6 clutches in this transmission, and one of them is a mechanical clutch. Here's a little bit on that front gear set. Now there is a sun gear that is splined. I know it's kind of hard to see on this drawing, but it's in gray there. That sun gear is splined to the stator support, so it's always being held. And this carrier assembly, you can see half of it here, and the other half is not really shown very well down there. But that front carrier assembly is splined, it's in blue, so it's splined to this 3.5R clutch housing. And then the internal gear, I'm going to erase everything. Then the internal gear is right here, and it's drawn in pink, and it's part of the input shaft. So my front gear set is really a mechanical gear set. My input is always the input internal, and held is always the sun gear, and output is always the carrier, and that output drives this blue drum, which is our 1, 2, 3, 4, 3.5R drum. So right from at the front of the transmission, going down the road, this drum is always spinning at a gear reduction, and that gear reduction's about a 1.5 to 1. It's like 1.53 to 1 or something like that. Just round it down to 1.5. And that's the reason why this transmission doesn't ever have direct drive as a gear option, is because you need to drive 2 parts at input shaft speed for direct drive to occur, and I can't do that. I only have one component that I'll be able to drive input shaft speed. Any of these other clutches are going to force these other gear set parts to spin at a gear reduction of a 1.5 to 1 gear reduction. On this slide, we're looking at the 3 driving clutches. And this is that 3.5R 1, 2, 3, 4 drum assembly. And it contains 2 clutches in it. So this is the drum assembly that gets spun at a 1.5 to 1 gear reduction all the time because of that front gear set. The clutch towards the front of the transmission is the 1, 2, 3, 4. The one towards the rear is the 3.5R. And then there's another driving clutch right here, which is the 4, 5, 6. Now the 1, 2, 3, 4 clutch housing, it grabs onto this shell right there, and that reaches all the way to the back of the transmission and drives the sun gear. The 3.5R clutch assembly grabs onto this shell and reaches back and drives the front gear set, or the front sun gear. There's another, if you notice, these splines are really long on this, this shell, this hub assembly, because I actually have 2 clutches that have the ability of working with that shell. I got my 3.5R, and on that side, and my 2.6 on this side. The 3.5R is an input, that's an I for input, and the 2.6 is going to be holding. So we'll see that here on when we talk about the holding clutches. But anyway, we only have the ability to drive 3 gear set parts. The 3.5R drives on the Ravenel, the rear gear set, drives the front sun gear. The 1, 2, 3, 4 drives the rear sun gear. And then the 4, 5, 6 clutch is going to reach in and it's going to drive the carrier assembly. We'll see more about that gear set here in a little bit. So looking at our input clutches here, I've got my 1, 2, 3, 4 clutch. And the 1, 2, 3, 4 clutch assembly looks like this. We've got a wave plate on the very bottom. That's a wave, and then it goes steel, friction all the way up to the top. And when it applies, it grabs onto this hub that goes in and grabs onto that rear sun gear, as I mentioned. And if that 1, 2, 3, 4 clutch is applied, it's going to spin that rear sun gear at a 1.5 to 1 gear reduction, because it's all coming through that front gear set on the 6L80 that's always working at a 1.5 to 1 gear ratio. And the 3.5R is going to be right there when that clutch applies through this clutch assembly, and we have a wave plate on it, and then go steel friction all the way up to the top. And it's going to go through and drive my front sun gear on that Ravenel gear set. Once again, at a 1.5 to 1 gear reduction. And here we've got our input shaft coming in for the 456. And the front of this drum assembly is where that front gear set is. That's always working at a 1.5 to 1 ratio, and it's always driving that 3.5R clutch housing. But right now we're talking about the 456. It's located on the other side of the input shaft. So this is the 456. And when this clutch applies, it's going to drive this like hub assembly. And this hub's kind of interesting. It looks like there's a clutch assembly in it, in this area right there. But when you pull the snap ring out, you just basically have this little weight in there and some friction material on it, but it's not driving anything. It's there for vibration, to kind of absorb some of the torsional vibration that occurs. And then the splines on the end of this shaft are going to go in and grab onto that little section of the carrier assembly. And this is a Ravenel type gear set. Ravenel. The Ravenel gear set basically has 2 sun gears in there. And you saw this on the overhaul video, but there's a smaller rear sun gear, and it drives a planet, and that planet drives a planet, and then that planet drives the internal gear. You can kind of see it in the background there. And then we have a single front gear set, or front sun gear, and that sun gear drives a planet, which drives the internal gear. And that internal gear is common. It's splined to the output. So when you build this thing up, you've got a single internal gear. It's in 2 pieces, but it acts as one when it's wrapped around that. So when the sun gear the rear sun gear is being driven, it's got to go from the sun to a planet, and then drive the internal gear. Whereas when the front gear set's working, it goes from the sun to the planet to the internal gear. We'll see more on that when we go over power flow. So our 2 holding clutches are going to be located in the center support area. The low reverse clutch is going to be on one side of it, and the 2.6 is going to be on the other side. And the low one-way clutch that I have in the picture right there, it actually lugs into or splines into the center section of this housing, the center support housing. And the center support housing, as you can see with these lugs, it's lugged into the transmission case. So this housing can't move. It is stationary, and neither can the center section. So nothing really in this moves. When a clutch applies, it's going to lock that clutch part to the transmission case. As far as the 2.6 clutch is concerned, if you remember, the 3.5R grabbed onto the front of this shell, and the 2.6 is going to grab onto the rear. And that holds this front sun gear on that Ravenel gear set. We got a series of frictions and steels, all that good stuff. The low reverse clutch is on the other side of that drum. So on one side we have the 2.6, on the other side we have the low reverse, and it has its own set of clutch packs. You could see here the low one-way is actually installed in that picture, and it's installed in this picture here as well. I'm showing how that carrier, see, this is kind of interesting because we've got the Sprag assembly is kind of, the outer race of the Sprag assembly is kind of long, so it fits into and grabs onto those low reverse clutch plates that are in there. So if I apply the low reverse clutch, I actually lock the outer Sprag race to the transmission case, because that's what it's doing. Remember, the center support actually is lugged into the transmission case. So if I apply this clutch, I'm going to lock this outer race of the Sprag to the transmission case. Well, located, I know it might be hard to see, but on the inside of that carrier assembly, you might be able to see those lugs right there. Right here, there's like little lugs. Those lugs fit into the lugs that are sticking out here on my Sprag, my outer Sprag race. So when this is assembled, if I apply my low reverse clutch and lock the outer Sprag race, I've also locked, because it's lugged to it, I also locked the carrier assembly from spinning in either direction. Now, as far as the low roller is concerned, the inner race is always locked because of the splines on the center section of this hub assembly. You can see those splines right there. So the inner race of the Sprag is always splined, to that center support, and that center support is always lugged to the transmission case, so that inner race never spins. So as far as the carrier is, since it's splined to the outer Sprag race, that one-way roller clutch is only going to be able to rotate in the clockwise direction, and if that carrier assembly ever wants to go counterclockwise, it's going to be held up by that Sprag. It's not going to allow it to, because that's a mechanical clutch. That's what it's supposed to do. Here's some more pictures on that Sprag assembly. If you look, here are those inner race. That's the inner race, and it lugs into the center support through those lugs right here, splines. Actually only fits on there one way. There's a spot on the inner race. I'm looking for it. I had it, can't really tell with the picture. But there's a set of master splines that keeps you from putting it on in any direction but one. You can see, barely, kind of see these under the little cage, little Sprag elements. They look like little peanuts. And they're kind of laying down in this direction. That was a bad drawing, sorry. And it's going to allow rotation in this direction, and then it's going to prevent rotation in that direction, the way it's drawn, or the way it's pictured right now. All right, and once again, these teeth right here, these internal splines around this carrier, they match up with the outer race, the external splines on the outer race. The frictions, the low reverse frictions, grab onto the bottom half, and then the top half, the carrier grabs onto. So, pretty neat design. Good way of doing it. So to help you understand this, the Powerflow, and Powerflow is beneficial for multiple reasons. One, it helps you understand when you're driving this vehicle what's going on. It really helps for noise diagnostics. If you get into a situation where a transmission's making noise and you have to isolate it down to maybe that front gear set, or maybe the Ravenel gear set, but you don't know if it's the front half of it or the rear half of it. This is a big deal, especially when you take it apart and you had this gear noise, and you diagnose it as gear noise, but then when you took it apart and you're looking at all these gears, everything looks good. And if you went through and identified exactly when the noise was occurring and when it wasn't, at least you have an educated guess when you throw parts at it of what you're doing. So let's take a look at this drawing and kind of figure out what is laid out and where. The input shaft is going to deliver torque coming in that way. And you can see I've colored in red. Everything in red is the input shaft. And so the input shaft is the internal gear. This is one of those things too, is make sure you understand as far as what's a gear and what's not. This is my kind of input shaft internal gear assembly. So I'd have internal facing teeth, and then they mesh onto the planetary gears, the planets, and the planets mesh with the sun gear. So I got my whole planetary gear set of the front gear set right here. And as far as the rear gear set, I've got my sun gear in the middle on the front half of the Ravenel gear set. I got my sun gear, so this would be I'm going to call that a front sun, FS, and this would be the rear sun of this one gear set. And if you notice this, I'll call this an idler, because there are two planetary pinions on this Ravenel gear set on that rear part of that Ravenel gear set. So I'd have a rear sun driving an idler, and then that idler would drive another planet, and then that planet would drive the internal gear. And the internal gear is the output. And on that front half of that Ravenel gear set, I got a front sun driving the planet, same one. I mean, it's not, but it's pretty much the same one. And then that drives the internal gear. So this is that kind of special gear set. It's not new. It's not like it was just invented. If you're a Ford fan, the AODs or 470Ws, even if you go back to Power Glides and all that stuff, they've been around for a while. So it's just not used that often. And then as far as what the clutches are doing, if we go back and look, our three input clutches are the 1, 2, 3, 4. Our three input clutches are the 1, 2, 3, 4, 3, 5R, and the 4, 5, 6. So the input shaft delivers torque coming in to the internal gear. This is this arrow with the sun gear in the green. It's showing it's going to the transmission case, so that means it's held. So that torque is going to come in through my planetary gear set, and it's going to have an output because I've got a medium size gear, which is my internal gear, driving a large size gear. So that's a minimum gear reduction, and it's at 1.5 to 1 gear reduction. So that drum is spinning at a 1.5 to 1 gear reduction, and in that drum, we've got the 1, 2, 3, 4 clutch and the 3/5R clutch. The 1, 2, 3, 4 clutch is applied. It's going to go ahead and rotate this rear sun gear at a 1.5 to 1 reduction. That's an R for reduction. I don't know why I wrote that. And then if that 3/5R clutch is applied, it's going to go ahead and rotate this front sun gear at a 1.5 to 1 gear reduction. If my 4, 5, 6 clutch is applied, it's going to go in and drive this whole carrier assembly. Everything is kind of sharing the same color scheme there. So if it's the same color, they're all connected. And that's going to be 1 to 1 because this is straight from the input shaft, straight to the carrier. So between those, okay, and I got to talk about my holding clutches here. Now my holding clutches, my 2.6, it has the ability of holding the front sun. So if you look, my front sun can be driven by the 3/5R or held by the 2.6. Obviously you can't do them both at the same time. And then the carrier assembly, going to that. So looking at my low reverse clutch has the ability to hold the rear carrier from spinning in either direction, whereas my low roller has the ability to hold that rear carrier assembly in the counterclockwise direction. So hopefully this little chart makes sense. If not, I suggest you rewind the video and watch it a couple more times until it does. So we're going to go through and look at the gears. This one here is first gear. So I pretty much omitted the clutches that aren't being used, even took out some of the kind of the connections like the 4, 5, 6, and there's no connection between the input shaft or the input housing and the rear carrier assembly. So I just left what is being used. So we do have the torque coming in from my input shaft, that is a given, and it's going to be driving this front drum assembly at the 1.5 to 1 gear reduction. I know you guys have heard that a million times. And with the 1, 2, 3, 4 clutch applied, it's going to go in and drive that rear sun gear at the 1.5 to 1 gear reduction from my input shaft. Now what's being held is my carrier. So my carrier assembly is holding. You can see it's being held through the low reverse clutch to the transmission's case. If you visualize what's happening, my rear sun gear is spinning at a 1.5 to 1 gear reduction. And that's going to cause, let's say I got clockwise rotation on it. That's going to cause counterclockwise rotation on my idler planetary gear. And it's going to cause clockwise rotation on the other planetary gear that it meshes with. And now I have an external tooth gear meshing with an internal tooth gear, and that's going to cause clockwise rotation on it. So between the reaction of the sun gear on a held carrier outputting a medium-sized gear with the addition of the 1.5 to 1 gear reduction being fed to from the front gear set, I've got my first gear ratio, which was 4 point whatever. Now if we were to look at this while it was spinning, while it was operating in first gear, we would have noticed that this sun gear, this front sun gear, would have been sitting there in idling kind of reverse. It would have been going backwards. The speeds would have been different. So when we shift into second, all they did was apply the 2.6 clutch. Because in first gear, the desire for that carrier assembly that was being held by the low roller was to make it spin counterclockwise, but that low roller prevented it from spinning counterclockwise. So the whole reaction that was happening by holding the carrier or allowing the carrier to be held was actually also causing this front sun gear to kind of spin in the opposite direction. So as soon as we shifted in the second, we applied this 2.6 clutch. That stopped this front sun gear from spinning. So now what's going to happen is the rotation of this carrier is going to have to continue around the stationary front sun gear. And when it does that, it causes this whole assembly to spin a little bit faster, or in a vehicle sense. I mean, that would do that on a dyno with no load, but in a vehicle, what would end up happening is it slows everything down. That's our upshift, right? Our 1-2 upshift. So the only thing that changed between the first shift and the second shift is we applied the 2.6, and that stopped that front sun gear from spinning, which stole a little bit of that gear reduction away and gave us our second gear ratio. In third gear, we don't have our 2.6 clutch applied anymore, and instead we applied our 3.5R And because of the action of our front gear set, we are driving at about a 1.5, both of these sun gears. That's going to cause this whole carrier assembly to spin at that, as if it was a single gear set there. So really this is about as close to direct drive as you can get. They are directly driving this rear gear set here. So what you're left with is the gear ratio that you have in the front. Because if this is spinning at 1.5 to 1 gear reduction, and this is spinning at 1.5 to gear reduction, these two parts that are inputting, it's going to prevent anything from spinning in that rear Ravenel gear set at a different speed. So it will spin as a unit, as an assembly. And what we're left with is the 1.5 to 1 gear reduction that we have in that front gear set. And that is about what the gear ratio is for third gear in this transmission. And now we shift into fourth gear. The 3.5R clutch is released, and our 4.5/6 clutch is applied. And we're directly driving this rear carrier assembly now, input shaft speed, 1 to 1. Yet we're still driving our rear sun at a 1.5 to 1. And because of the nature of these little planet pinions and so forth spinning around that slower moving 1.5 to 1 sun gear, we get a little bit of a gear reduction in the back, but it's not much. It's pretty close to 1 to 1. I think it's like 1.15 or 1.18 to 1. So it's a pretty modest gear reduction. So this might not have direct drive, but this is about as close as you're really going to get to it. Now we shift into fifth gear, and our 3.5R clutch applied, our 1, 2, 3, 4 clutch released. And what's going to happen here is we're going to drive this front sun gear to 1.1 to 1.5 to 1 gear reduction. We're still driving our carrier at a 1 to 1 gear ratio. And the way this works, a little different than the rear gear set, is that this front sun gear is spinning slower than the input shaft, and this carrier spinning input shaft speed. Since this front sun gear is spinning slower than the input shaft, it's going to actually force that the internal gear assembly, the Ravenel internal gear assembly, to spin faster than the input shaft. So this is going to be our first overdrive that we have. So we have a input shaft driven carrier assembly, slower moving sun gear, faster moving internal gear. So when we shift into 6, our 2.6 clutch applied, our 3.5R clutch released, and we stopped that front sun gear from spinning. So now what we have is our input shaft is still driving that carrier. That's the input, large gear input, medium-sized gear output, small gear being held. That's the best overdrive I can get out of this gear set. No, it's not. That's the medium-sized overdrive that I can get out of a gear set, but it happens to be the biggest overdrive they've got in the 6L80, which is a 0.67 to 1 overdrive, which is a pretty good overdrive. And so that's how they do it. They basically hold this sun gear and output the internal gear, which is always output anyway, but they input that carrier from the 4.5/6 clutch being applied, delivering torque from my input shaft through the clutch right to the carrier. That's how they get overdrive, or 6-gear overdrive. In the reverse, typical gear set rules still follow. We're going to want to have a carrier being held, so our low reverse clutch is going to hold the carrier assembly. So it's going to be holding it to the case. And then I'm going to drive through my 3.5R clutch. I'm going to drive my sun gear. And so I've got a sun gear that's input. It's going to rotate clockwise, cause counterclockwise rotation of my little pinion gears there, or in this case, big pinion gears. And that causes counterclockwise rotation of the internal gear because an external tooth gear driving an internal tooth gear, same direction rotation occurs. As reverse. Now let's look at the clutch pack clearances that we have. The only clutch that doesn't have an adjustable clutch pack clearance, or even a spec for that matter, is the 2.6 clutch assembly. And they're all adjusted by snap rings. The way they want you to measure it is they put a 10-pound weight on top of the clutch, and then they air check it, and you measure the movement of that weight assembly. It's called like a travel weight, they call it. So they put it on there, and when you're air checking, you measure how much travel that weight is occurring or going through. The specs are up here. You can see this 3.5R is expecting between 48 and 70 thousandths to 1, 2, 3, 4 between 60 and 78 thousandths, and that is with the weight on it. Now, most people don't have that weight or they don't want to mess with it. I mean, it is 10 pounds, which isn't heavy. It doesn't flatten out any wave plates. It just kind of takes out some of the irregularities if something's not sitting perfectly flat. I noticed when I was doing most of the measurements that if I put 10 pounds with the weight on it, even if I'm just using finger force, I'm changing the clutch pack clearance by about maybe 5 and 10 thousandths at the most. So if you're on the tight end of these specs, as long as you're not under it, you know the spec is going to only get better with the weight on it. So like if I had 50 thousandths on my 3.5R and I put weight on it, it's going to go to 55 or 60 thousandths worth of clearance. Because remember, you're putting the weight on there and then you're checking the movement. So you're taking out any unevenness in those clutches. So that's going to gain you clutch pack clearance when you put that weight on. Now, if I was in the high end of the spec, if I was already at 68 thousandths and I don't have any weight on it, then I would be concerned and probably want to change the snap ring in it. The 456 between 50 and 74, you can see there's 3 sizes of snap rings for it. And then the low reverse, you're allowed between 50 and 81 thousandths. So the clutch pack clearances aren't crazy. 27 thousandths of a window there, 30 thousandths of a window there, and they're all done with weight. So if you don't have a weight and you're going through and checking these things, you might add 5 to 10 thousandths to whatever you've measured without the weight, because that's realistically what your clearance is probably going to be according to their specs, like if you're referencing their specs.